Hello students, welcome to my class. Today I am going to discuss few questions related to this chapter, that is the chapter number 5, state of matter. I have discussed the theories related to this chapter. I have discussed about Charles' law, Boyle's law, Gay-Lussac's law, ideal gas equation, Dalton's law of partial pressure. Then I have discussed about surface tension, viscosity, critical temperature. I think you people remember this. So now we are going to utilize these topics in the form of questions. Clear, my friend? So let's start the topic here. That is my first question. Look at what is given here, my friend. Wait for a moment. This is the question number 1. What is the answer of this question? What would be the SI unit for the quantity of PV square T square upon N? Okay. As we know, P is for pressure. Yes, sir. P is for pressure. Pressure is equal to Newton per meter square. Yes. This is V is for volume. Volume is, my friend, meter cube. Yes, sir. And the temperature is, my friend, Kelvin. Clear? And N is equal to, that is mole. Clear? Now put this value, what we get here, that is N upon M square, yes, multiply by M cube multiply by K divided by MOL, mole. Am I right? Yes, sir, you are right. Now again modifying N upon M square into meter cube into K for Kelvin upon mole. Now what will happen in this case, my friend? This will cancel this one. We can write Newton meter Kelvin per mole. This is the case. Again I am repeating, Newton meter Kelvin per mole. Check out the thing. P Newton per meter square. V, one more thing I am going to add a mistake here, V is square. So there will be the square, my friend, M6, that is the cube. We can put here M6. Now what will happen is cancel, that is we get M4. So Newton meter 4, clear, then Kelvin upon mole. This is the case. One more thing, here is T square, again need to modify. This is the K square, this is the K square, this is the K square. So Newton meter 4 Kelvin square per mole. Now perfect. Am I right? Yes, sir, you are absolutely right. Now I am going to rub this part, my friend, and we'll discuss the next. What is given? The next question. Now the next question is, look at the question number 2. It's very easy. What is given here? What is the significance of van der Waals constant A and B? We people know that is the van der Waals gas equation for real gases. A, what is the significance of A? It measures the magnitude of intermolecular forces of attraction, clear, between the particles. Again I am repeating, it measures the magnitude of intermolecular forces of attraction between the particles. And what is B here, my friend? That is B here is the measure of effective size. It signifies, or you can say it measure the effective size of the molecule. Clear? Again I am repeating, it measures the effective size of the molecule. This is the significance of A and B. Clear? Now I am going to rub this part, my friend, and we will discuss the next one. What is given? Wait for a moment. This is the question number 3. what is given here? Read the question carefully, my friend. Wait for a moment. Now, the solution of this question. At 0 degrees Celsius, the density of a certain oxide of a gas at 2 bar is same as that of dinitrogen at 5 bar. What is the molecular mass of the oxide? Now, first of all, relation. Given here, density of the first gas equal to the density of the dinitrogen. Now, what is the formula of density in terms of PV, RT and molecular mass? We people know PV is equal to nRT. Yes sir. P is equal to N upon, or it's better to write like this. PV is equal to given mass upon molar mass RT. Yes sir. Now what will happen? Pm is equal to given mass upon volume RT. As we know, density is equal to mass upon volume. So Pm is equal to rho RT, that is the rho 1 and rho 2. So rho is equal to Pm upon RT. Am I right? Yes sir. So put this value. What is given here? That is rho 1. Rho 1 here, that is we can write here P1 M1 RT. Yes sir. Now what is for dinitrogen? That is P2 M2 upon again RT. Clear my friend? Temperature remaining same, not 0 degree my friend, that is Kelvin, 273.15 Kelvin. Now what will happen? Look at this one and this one and this one and this one will cancel each other. Yes sir. What is the value of P1 here? We get here now P1 M1 is equal to P2 M2, or you can say M1 is equal to P2 M2 upon P1. Yes sir. Now what is P2 here? That is my friend 5 bar. Am I right? Yes, put here 5. What is M2? This is dinitrogen. Mass of dinitrogen is 28. What is P1? P1 is equal to, it is given here my friend, that is 2 bar. Am I right? Yes sir. So put here 2. Now what will happen? That is 14 and answer will be 70 gram. Am I right? Yes sir. This is a simple question and you can easily solve such kind of questions my friend. Now I am going to rub and we will discuss the next one. What is the next question? That is the question number 4. Read the question carefully. What is given here? A student forgot to add the reaction mixture to the round bottomed flask at 27 degrees Celsius. That is T1 here is given 27 degrees Celsius. That is 27 point around 273. This one is 300 Kelvin. Yes. But instead he placed the flask on the flame. Okay. After a lapse of time he realized his mistake and using a pyrometer, okay, using a pyrometer he found that the temperature of the flask was 477. Now we can write here T2 is equal to 477 degrees Celsius. That is 477 plus 273 my friend. Clear? 477 plus 273. Now add them 477 plus 273. What we get? That is 850. So what I am getting here, that is 850 Kelvin. Am I right? Yes sir. Wait. 473, 73, 10, 774 and 15, 426, 750. Yes, it is 750, not 850. Clear to you? Again check these things. Now what is given here? What fraction of air would have been expelled out? This is the case. What fraction of air would have been expelled out? We know V1 upon V2 is equal to T1 upon T2. This is a Charles law. Yes. Now V1 upon V2 is equal to T1 is 300 upon T2 is 750. Now this will 15 5, that is 2 by 5, fraction is 2 by 5. So what is given here, the what fraction of air would have been expelled out. So the fraction of air expelled out is equal to 1 upon 2 by 5, that is 5 minus 2 by 5, that is my friend 3 by 5. This is the case. So the fraction of air expelled out is 3 by 5. It's very simple and you can easily solve such kind of question. These all questions are from NCERT book. As I told you earlier, NCERT book is one of the best book for solving the problems. So let's move to the next one, the next question also. Now read the question. This contains 3 marks, 2 part. Clear? First of all, we are going to solve the first part. What is given here? Calculate the temperature of 4 mole of a gas. That is, N is equal to given my friend 4 mole, okay, of a gas occupying 5 decimeter cube. That is, volume is given 5 decimeter cube, okay. Pressure is given my friend 3.32 bar, okay. R is given also and we have to find out the temperature. Now is there any relation between this data? Yes. Now the solution of question number 1. Clear? P is given 3.32 bar. Yes. V is given 5 decimeter cube. We do not know the value of T, and N is given here 4 and R is given here 0.083. Clear? Now the link is ideal gas equation. As we know, PV is equal to nRT. Now T is equal to what will happen, my friend? PV upon nR. What is P, my friend, here? 3.32. So put the value 3.32. What is V here? 5. What is N here, my friend? 4. What is R? 0.083. After solving, you get the value of T. P, V, T, N. PV is equal to nRT. T is equal to PV upon nR. Am I right? Yes, sir, you are absolutely right. Now, what is the next part of the question? This is very simple question. How much time would it take to distribute 1 Avogadro number of wheat grains? As we know, Avogadro number is 6.022 into 10 to the power 23. If 10 to the power 10 grains are distributed each second. What is given? 10 to the power 10 grains are distributed each second. So, what would be the answer of this question? How to solve this question, my friend? Solution number 2. Clear? Avogadro number of wheat grains, if 10 to the power 10 grains are distributed each second. Number of grains distributed each second is equal to 10 to the power 10. And what is the amount, total number of grains? Number of wheat grains. What are the number here, wheat grains? That is equal to Avogadro, that is Na, that is 6.022 into 10 to the power 23. Clear? So the time required to distribute this will be, that is the time required will be, my friend, 6.022 into 10 to the power 23 divided by 10, my friend, 10 to the power 10. Am I right? Yes, sir. Now we can write here 6.022 into 10 to the power 23 minus 10, that is 6.022 into 10 to the power 13 second. If you want to convert it into year, into day or anything, you can easily convert. These are the two questions complete. Now let's move to the next segment, my friend. Wait for a moment. So, read the question number 6. A mixture of dihydrogen and dioxygen at 1 bar pressure contain 20% by weight of dihydrogen. Calculate the partial pressure of dihydrogen. Clear, my friend? Yes. As we know, partial pressure of dihydrogen is equal to mole fraction of dihydrogen multiply by total pressure. This is the formula. Yes. Now what we need to find? Pressure is given, total pressure 1 bar. It is quite easy. It is given here 1 bar, but we do not know the mole fraction of hydrogen, my friend. Yes. So we know mole fraction of hydrogen will be equal to number of moles of hydrogen upon number of moles of hydrogen plus number of moles of oxygen. Clear? Now what are the number of moles of hydrogen? That is the given mass upon molar mass. What is the given mass here, my friend? That is 20%, that is 20 upon the molar mass of hydrogen is 2, that is, my friend, 10. Yes, definitely. What is the number of moles of dioxygen? What is the mass? 20% dihydrogen, so 80, that is the 80 gram upon 32. Oxygen molar mass is 32. Clear? Now what will happen? 5 upon 2, that is 2.5. Clear? Now what is the mole fraction of hydrogen? That will be equal to 10 upon 10 plus 2.5, that is 10 upon 12.5. Am I right? Yes, sir. This is the mole fraction of hydrogen. Moving here, that is the partial pressure of hydrogen will be equal to mole fraction is given 10 upon 12.5 multiply by 1. Am I right? Yes, sir. Now the answer is partial pressure of hydrogen is 4 upon 5 bar. This is the exact answer. Clear? Now let's move to the second part. What is the second part here? Am I visible? Critical temperature of carbon dioxide and water is given respectively. Which of these has a strong intermolecular force and why? This is a very simple question. As I see here, carbon dioxide has critical temperature 31.1. As we know, higher the critical temperature, easier is the liquefaction. Easier is the liquefaction, that means to say the intermolecular forces increases. So the compound, the substance which have higher critical temperature, then it will have high intermolecular forces. Clear to you? Because when gas convert to liquid, what will happen? The particle come closer, then that means to say there is a increase in the intermolecular force. Am I right? Yes, sir, you are absolutely right. This is a true statement. Now I am going to rub this part and we'll discuss the next one, my friend. Wait for a moment. Now let's move to the question number 7. What is given here? It is very simple. Value of universal constant, moving. value of universal constant R is same for all gases. What is its physical significance? That is the case. Okay. As we know, PV is equal to nRT. Yes. R is equal to PV upon NT. Yes, sir. And we know P is pressure, V is volume. The standard unit, that is Newton meter square, and volume is meter cube upon what is the N, mole, and this is Kelvin. Clear? What we observe here, this one will cancel this one. R unit is equal to Newton meter per mole per Kelvin. This is the case. As we know, Newton meter is equal to Joule. Joule per mole per Kelvin. As we know, Joule is the unit of work. Yes. So, what is the physical significance of R? R is work done per mole per Kelvin. Clear to you? What is the significance of R? R is actually the work done per mole per Kelvin. Again I am repeating, R is work done per mole per Kelvin. Am I right? Yes, sir, you are absolutely right. This is the physical significance of R. I think you understand it and you can note it down. Clear, my friend? Now, let us move to the next question. What is the next question? Wait for a moment. Now, this is a big question. Read the question carefully what is given. One of the assumption of kinetic theory of gases, again I am repeating, one of the assumption of kinetic theory of gases states that there is no force of attraction between the molecules of a gas. How far is this statement correct? Is it possible to liquefy an ideal gas? According to this statement is completely correct for ideal gas. There is no force of interaction between the molecule of a gas. But if there is no force of interaction between the molecules, then the gas cannot be liquefied, because when gas liquefy, there is a force of interaction operates between the particles. Otherwise, the liquefaction is not possible. So, this statement is not completely correct. Clear? For ideal gas this is correct, but when you liquefy there is the existence of intermolecular force of attraction. If there is no existence of intermolecular force of attraction, then liquefaction is not possible, my friend. Complete explanation, you can easily do such kind of questions. It's up to you how to solve this one. Now, what is given here? Next question is very simple. Name the intermolecular forces that exist between HF molecules in liquid state. As we know, when HF molecule, that is there is a polarity delta plus and delta minus, and when it associate with other hydrogen, that is delta plus and delta minus, there is two possibilities due to this delta plus and delta minus. There is dipole interaction. Yes, first force is dipole interaction, and the second force we know that is due to the polarity, difference in polarity, there is a famous bond take place. This bond is hydrogen bonding. As I told you earlier, hydrogen bonding is not bonding, it is just a force. So, two forces operate, dipole interaction and hydrogen bonding. Clear? Dipole interaction and hydrogen bonding. Now, I am going to rub this part, my friend, and we will discuss the next question. What is given? The next question, check it out. The next question is question number 9. Again, the big question. Think on it, what is given? This is the van der Waals gas equation, where A and B are van der Waals constant and NB is approximately equal to the total volume of the molecule of a gas. A is the measure of magnitude of intermolecular force of attraction. As I told you earlier, arrange the following gas in order, increasing order of O. Give reason. As we know, if the size increases, the value increases. The value of B increases. Which have more size? Tell me. Look at oxygen का CO2 H2 less size than helium, then there come oxygen, then CO2. That is the order here, that is my friend hydrogen, then helium, then oxygen and then CO2. This is the case. Again I am repeating, hydrogen, helium, oxygen and CO2. Am I right? Yes sir. Because if size increases, the value of B also increases. Hydrogen has less size, so hydrogen comes below. Then CO2 has maximum size, so it will have more value of B. Now next one. Arrange the following gas in the decreasing order of magnitude of A. As we know, again CH4 has higher intermolecular force of interaction. So CH4 has higher intermolecular force of attraction, so it will have, that is the magnitude of A is more. So the order here is CH4, then there come O2 and then there come my friend H2. This is the order. Again I am repeating, CH4, O2 and then H2. Am I right? The question looks big, but it is not so much big. Simple explanation are there. Clear? Now wait for a moment. Give me a few seconds. Now let's move to the next one. Again this is a big question. What is given here? The relation between pressure exerted by an ideal gas and observed pressure is given by the relation P ideal is equal to P real plus AN square upon V square. Clear? If pressure is taken in Newton per meter square, number of mole in mole, unit amount of substance is mole, and the volume is meter cube, calculate the unit of A. I think you have got the question. What we need to find? We need to find the unit of A, my friend. This one, this is the value. Okay. Now what to do? I am moving here, check it out. We know P ideal is equal to P real plus AN square upon V square. P ideal is equal to P real plus AN square upon V square. That is, we need to find this one, A. Okay. What to do? P ideal minus P real is equal to A. What is the unit of N? That is mole square. And what is the unit of V? That is, my friend, meter cube square. As we know, P ideal Newton per meter square minus Newton per meter square. What we observe, this is completely the pressure, as we have studied in physics also, unit and dimension. So do not write 0, my friend. So this will get Newton upon meter square. Now A mole square upon meter cube into meter cube. Now what will happen? This one will cancel this one. So we will write here Newton meter cube and 1 meter, that is meter 4 is equal to A upon mole square. Yes sir, definitely. So we people can say A is equal to Newton meter 4 upon mole square. This is the first unit. Now what will be the unit of A when pressure is taken in atm and volume in decimeter cube? Not an issue. This is the first unit. Now I am starting from here. Again the next part, that is, as we know, here is pressure, this is SI unit Newton per meter square, and again here telling that is ATM, and A upon mole square upon what is given meter cube, we have to take here, that is decimeter cube according to the question. So put here decimeter cube into decimeter cube. Am I right? Yes sir. Now the next one is what will happen, that is we can write the unit of A, multiply, that is ATM decimeter 6 upon mole square. Yes sir. ATM decimeter 6 upon mole square. This is the next one. ATM decimeter 6 upon mole square. This is the unit of A. Am I right? Yes sir, definitely you are correct. Check out the things. Depend upon the situation which type of unit you are taking, SI unit or normal unit. Clear? Now what is the next part of the question? This is, name the two phenomena that can be explained on the basis of surface tension. We know the spherical shape of the bubble and the capillary action. This topic is completely basically belong to physics, surface tension. Still there is a small introduction in your chemistry also, that is the liquid state. So what are the phenomena that can be explained on the basis of surface tension? It's very simple, a spherical shape of the gas bubble or a spherical shape of the water bubble, and the second one is the capillary action. Clear? Yes sir. Now the next one, explain the effect of increasing the temperature of a liquid. Moving. The answer what is given, express the effect explain the effect of increasing the temperature of a liquid on intermolecular forces operating between its particles. What will happen to the viscosity of the liquid if its temperature is increased? Yes, as we know, what is the viscosity? The internal resistance, or you can say internal friction between the particles. Okay, this is, if the temperature increases, when temperature increases, what will happen? The internal resistance, that is the interatomic interaction, or we can say the layer, the interaction between the layers, power decreases, and the particles will easily move or slip over one another. So what we say, with rise in temperature the viscosity decreases and the liquid starts to flow. Again I am repeating, with rise in temperature, viscous drag, viscosity decreases, my friend. That is, the particle start moving, start flowing easily. This is the case, my friend. Am I right? Yes. Now I have discussed each and every question, each and every topic related to this chapter. Still, if you have any doubt related to any question from any book, you can easily approach to me, my friend. I am always here to serve you. So memorize all the techniques, revise the chapters, check out each and every theory, and definitely, my friend, you will get beneficial. So my friend, time has come, time to say bye bye. Thank you so much.